Good morning, everyone. I'm Santiago. Today I'm going to tell about nanocrystalline and materials. And fascinating are to modern material sciences. This presentation is based on the article written by C. Suryanayama from the University of Idaho. Uh, this uh, it reviews the structure, synthesis, and properties of these materials and explains why they are considered one of the most promising develops in the material research. Definition and basic concept. What are the what what are nanocrystalline materials? Um, they are polycrystalline materials made of extremely small grains, usually less than 100 nanometers in size. Because of this tiny scale and very large number of atoms are located at the grain boundaries, much more than is normal coarse grained materials. This is special atomic arrangement gives nanocrystalline and materials unique physical and mechanic properties. In the other words, by simple reducing the ground size, we can make the some materials behave in the completely different way. Stronger, harder, or even more resistant to heat and wear. Background and motivation. For centuries, metallurgists and materials scientists have searched for materials that are stronger, lighter, and more heat resistant. During the 20th century, 20th century, uh, new processing methods operate like rapid solidification, plasma processing, and mechanical alloying. They allowed scientists to reach new non-equilibrium structures, reducing the ground size to the nanometer scale become one of the most effective ways to change the properties of the solid and create what we will call nanocrystalline materials. Classification. Okay, I got it. According to sorry, according to Suryanayama, nanocrystalline materials can be classified based on their structure of or density. There are one, three-dimensional crystals, which are schiacal nanocrystals, two-dimensional filamentally nanostructures, one-dimensional larger nanostructures, and zero-dimensional clusters, which are atomic group or particles. Each type and specific properties applications. For example, three-dimensional crystals are often used the structural and magnetic materials, while the larger structures are and useful in electronic and coatings. Synthesis methods. There are many techniques of producing nanocrystalline materials. Some of the most common are inert gas condensations, mechanical allowing, and spray conversion processings. In the inert gas condensation methods, metals are evaporated inside a vacuum chamber filled with an inert gas like helium. The atom collides, loses energy, and condenses into very fine nanoparticles that can later be compacted into bulk materials. Mechanical alloying is another very popular technique. In it involved repeatedly wielding and futuring metal powders in the high energy balls mills. This process can be produced nanocrystallines alloys is large quantities and the relative low cost. Spray conversion processing is often used to produce nanocrystallized composites such as tungsten carbide callback. And this method starts from chemical precursors and use high temperature um, reactions to create powers with grain size between 20 and 40 nanometers. These methods have allowed companies to start producing nanocrystalline powders commercially, including material like titanium dioxide, aluminum oxide, tungsten carbide. Thank you for hearing the exposition. Thank you.